Hello everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching Sankalp KCET 2026, and we are discussing the most important chapter of your KCET exam, that is current electricity. 5 to 6 questions are guaranteed from this chapter. 5 to 6 questions, not 1, not 2, but 5 to 6. Up to 7 questions came from this chapter, but I don't expect 7 questions will come in KCET 2026, but 5 to 6 question you can expect from this chapter in KCET 2026 as well. And today is part 2 of this chapter, and we are going to discuss cells, Kirchoff's laws and Wheatstone Bridge in this part. If you have missed part 1 of this chapter, then go back to our channel and watch the part 1, and then you can come back and watch this video. But definitely you have to watch part 1 because that is also, as I said, this is the most important chapter for your KCET exam. In the next class we are going to solve the previous year questions from this chapter for KCET, and then also we are going to do the JEE questions from this chapter as well. So let's look into the first, before going into our lecture, let's look into our achievement from last year. So you can see these students, Prajwal, Diksha, Sachin, they all have studied from us, from our YouTube channel, and they have achieved the beautiful rank that you can see here. Also there are a lot of students here that we cannot show all of the pictures in this small slide, but I can guarantee you, if you are following our channel, following our lecture, or not only me but all the other lecturers lectures, then definitely you can be here next year, right? Will it be you? So that choice is up to you. If you are following our channel from the beginning, congratulations, you are in the right track. But if you are not, then you have to start following our channel. Subscribe to our channel if you have not yet subscribed, right? So let's look into the chapter brief. Here we have electric current, Ohm's law, limitations of Ohm's law, then resistance and resistivity, combination of resistance, drift velocity, conductivity and mobility, also electrical energy. These, everything of these concepts are covered in our part 1. So if you have missed, you can go and check them out. In this part we are basically going to discuss about cells, cells in series, cells in parallel, as well as Kirchoff's law, Wheatstone Bridge, and some of the applications of Kirchoff's laws. So these are the main tasks today. Even though the list is small, the application part is more from this part. Okay, so if you consider concept wise, these are a lot of heavy concept. This is not super conceptual. Some formulas are there, some concepts are there. Other than that, a lot of applications are there from this part. So please check this video till the end. First concept that we are going to discuss is cells. So electrical cells, what is the meaning of electrical cells? So far, if you remember, we generally do not differentiate between electric cell and electric battery. So most of the time, whenever we see this symbol, we say this is a battery, right? This symbol we are associated with battery, but battery is slightly different than electrical cell. Also here electrical cells means a practical cell, not an ideal cell. What is the difference between ideal cell and a practical cell? Ideal cell generally do not have a resistance of its own. Okay, so the ideal cells do not have a resistance of its own. So far, whatever circuits that we have studied, mostly they are ideal cells, and even in future also most cases we will see ideal battery or ideal cells only. But in this chapter we are also going to see some practical cells where the cell itself has a resistance of its own. So that is the basic difference. Not between battery and cell. Battery is something different, we will see that as well, but you have to remember that cells generally have an internal resistance, and internal resistance of a cell can always be represented by a small resistance, and it is always connected in series with the external cell. Okay, so here E generally represents the EMF of the cell, and in our lecture we will represent this E by, not by E but with epsilon. Okay, sometimes it is difficult to understand. So epsilon and E are same. Okay, epsilon and E are same. Epsilon is the internal EMF of the cell, so that means it is the original EMF. stands for the electromotive force. Okay, that is also in terms some way colloquially we say voltage. Even though the voltage will be wrong, EMF is actually the correct term. So EMF gives you also the unit of EMF and voltage are same, volt. Okay, that is the only similarity. But you have to understand that when I say EMF means the actual voltage of the battery, the real voltage of the battery. But when we apply this cell into a circuit, we do not get that actual voltage, but we get something reduced, some reduced value than this actual E. Okay, so we know that ideal and practical, we have learned that in thermodynamics as well. Okay, there is a difference between ideal and practical, right? So ideal means if you do not have this external resistance or internal resistance of the cell, then it is called ideal. So whatever is EMF, the same is the voltage. EMF and voltage would be same. But in case of practical circuit, we cannot ignore this small resistance. This resistance is the internal resistance, generally small, but you cannot ignore it completely. And when you connect it with the external resistance R, as you can see, it is connected in series with this external resistance. Okay, so current is constant in the circuit. So current constant means it is a series combination. So in that case, you can say that the voltage that you measure across the cell. Now this entire quantity, you cannot separate this R from this cell. This is always hidden inside the cell. So even if you take a small cell, electric cell, okay, it's mentioned 1.5 volt, that means it is the terminal voltage. Terminal voltage, but actually when you apply it into a circuit, the voltage actually reduces from that 1.5 volt. Okay, this is the actual voltage that you measure. So when you take a voltmeter, suppose you take a voltmeter and if you apply it over here, then you will see that the voltmeter showing a value of this epsilon minus IR. So what is I? I is the current in the circuit, and if you extract this IR part due to this small resistance, then that will give you the actual voltage across this cell, right? So this is the this is called the voltage of the cell when it is connected in the circuit. Depending upon the circuit, the current I will change and this V will change as well. Okay, and for voltage we can apply obviously the Ohm's law. From Ohm's law we can say that V is equal to IR, and from there you can even calculate the current of the actual cell. It is very easy. If you learn Kirchoff's law, you can even directly apply this. You don't need to think too much. Or even if you don't know Kirchoff's law, you can apply that this resistance and this resistance are connected in series. So the equivalent resistance is R plus R, small r plus capital R. If you divide it by the EMF of the cell, you will get the current in the circuit. That way also you can calculate the current. Now as you can see that based on the value of R and capital R, the current in the circuit changes, and based on that the measured voltage also changes. Okay, now let's see one question, one easy question that came simply from this concept only. The variation of terminal potential difference with current flowing through a cell is as shown in the EMF and internal resistance of the cell R. So here we can see that here this is the voltage across the terminal of the voltage, terminal potential difference. This is the terminal potential difference, that is when you connect the voltmeter across the terminal. Okay, and this is the current in the circuit. Both are changing. As you can see, this is the graph. This line represents the graph. Now how can you calculate the EMF and the internal resistance? Now to calculate EMF, you have to understand that we know that EMF and voltage relationship, this is the terminal voltage, and EMF is given by epsilon minus IR, right? This is the relationship between voltage and terminal voltage and the EMF. Right? Now here you have to understand that if you somehow can make this current equals to 0, then voltage, terminal voltage becomes the EMF of the cell. Right? Now if you see this graph carefully, what is this axis? This is the y-axis. Now what is the equation of y-axis? Equation of y-axis is x equals to 0. right? So that means that the equation of voltage axis will be current equals to 0, right? So equation of this axis is current equals to 0, this axis, right? So from here we can see that whenever it is intersecting this graph, whenever it is intersecting the y-axis, at that point, at this point, okay, the current is 0, right? Current is 0. So from here we can say that voltage at this point is equals to epsilon, that is the EMF. So from here we can say that 3 volt is basically the terminal, the EMF of the cell. So 3 volt is the EMF of the cell, right? Now this is fine. Now what else? Now again we will use the another concept that along this axis, along the volt V axis, this basically represents V equals to 0. This axis is V equals to 0 axis. X-axis equation is y equals to 0. So y is here voltage, terminal voltage. So that V must be equals to 0 for this axis. So when this intersect at this point, that means at this point V must be equals to 0. Epsilon cannot be 0. Remember that epsilon cannot be 0. Minus I here is 6 ampere. 6 into small r. Now epsilon value we have already calculated, 3 volt. So from there we can say that 6r must be equals to 3 or r equals to 0.5 ohm. Okay, so the correct answer is 3 volt 0.5 ohm. So option D is correct. Okay, now let's move on to cells in series. So that's what I was talking about in the beginning, that if you remember, what is the difference between cell and a battery. So battery is basically when you connect multiple cells, those are called battery. Okay, battery generally has more than one cell. For example, if you open the back of your remote, you will see that it requires 2 cells to operate. Okay, so the combination of those 2 cells can be considered to be a battery. In most cases we will use the cells in series for practical purposes. In some very specific cases we might use cells in parallel as well, but in the perspective of theory you have to learn both, and cells in parallel sometimes is more important in not only in KCET but other exam, JEE and NEET exam also, cells in parallel is equally important. But for KCET students, cells in series is mostly common, 90%, but there are 10% questions which based on cells in parallel as well. Now let's see what is the meaning of cells in series. Series combination is very simple, where we connect multiple cells one by another. Okay, it can be multiple cells, each one have epsilon 1 and internal resistance R1, epsilon 2 R2, epsilon 3 R3, like that. Okay, now this entire thing is connected across an external resistance. Okay, so this is how the cells are connected. Now here we are assuming everything is connected equally. That means positive, negative, positive, negative. Now what will happen if we invert one of the cell? If we invert any one of the cell, what will happen? Then you have to subtract it. In this case, everything will be added. Now you have to understand that in case of series combination, current in the circuit remains same. Now because this is positive, everything current is going in this direction. So I am taking the current in this direction. Okay. Now what is our target? Our target is to convert it into a simple circuit having only one cell and only one internal resistance. That is our target. External portion will remain the same. Internally it will be epsilon equivalent, R equivalent. Now derivation is part of the syllabus, but I am not going to do the derivation in this lecture particularly. For PU focus lecture, which will come very soon, don't worry, I will try to give you as soon as possible. So during the PU focus lecture I will do the derivation. And in this case I will not solve too many questions based on KCET, right? That will be mainly focused on your PU board exams. Now here the derivation is, if you derive the expression, you will get that equivalent epsilon is basically given by epsilon 1 plus epsilon 2 plus epsilon 3. So as simple as that, like you used to do in case of series combination of resistance, all the resistance generally gets added. Here resistances are also getting added. Not only that, the EMFs are also getting added. So total EMF will obviously be higher, total resistance will also be higher. Okay, so the case where you are adding the circuit in series combination, when you are adding the circuit in series combination such that the current in the circuit remains same, so in that case the equivalent resistances, equivalent EMFs are getting added, and for equivalent resistances are also getting added, and the current in the circuit is given by this formula. Okay, based on this formula, you might expect one numerical question also in your PU board exam. I think this year one question in the first paper, there was one question came from the parallel combination, not series combination. So if you apply that concept, you could have solved the questions easily. And next is, let's see one question. A car has a fresh storage, a battery of EMF 12 volt and internal resistance 2 into 10 to the power of minus 2 ohm. So battery means more than one cell. Okay, if the starter motor draws a current of 80 ampere, then the terminal voltage when the starter is on. Okay, so battery EMF is given by 12 volt. Okay, battery is given by 12 volt. The internal resistance is given by 2 into 10 to the power of minus 2 ohm. Now if this is a very easy question, okay, the current draws by the circuit is 80 ampere. So current drawn by the circuit is 80 ampere, and they ask you what is the terminal voltage. Terminal voltage is V, so V is basically epsilon minus I into R. So just put these values. So this is a KCET question, I forgot the year, but this is a very common type of KCET question, so you can expect similar question might come in your KCET exam as well, and you just need to put the formula and solve it. 2 into 10 to the power of minus 2, so it will be 160, 161.6, so 12 minus 1.6, that is 10.4. Okay, 10.4 volt. So correct answer is option A, 10.4 volt, right? Now cells in parallel, here the things get little complicated in terms of derivation, but as I said, derivation I am not doing in this class. But parallel combination, as you know, parallel is same, the voltage will remain constant, current will vary. That is why now here we are only connecting cells. So voltage, you might say, sir, voltage, what will be the voltage? So voltage will remain constant, by the way, in case of no matter what you are using, cell or resistance in parallel combination, voltage always remains same. There has to be some common voltage. That common voltage itself is the equivalent voltage. Okay, there can be multiple cells in between. Now our target is same. Target is always same. Okay, target is always same. Simplify everything. So it is epsilon equivalent, R equivalent, and this is R. Whatever current was flowing in the circuit, the same current should flow in this case. That is our primary objective. Okay, not only simplify the circuit, also the current in the circuit should always remain the same. Now the equivalent EMF for in this case is little complicated. It is given in this form. This is the easiest form to remember. Okay, why so? Because if you see the denominator, it is nothing but 1 by R1 plus 1 by R2 plus 1 by R3, that is the equivalent 1 by equivalent resistance. Okay, and you can write this, this is another form. Here you can write epsilon equivalent by R equivalent equals to given by this form. Okay, you can calculate the R equivalent easily. Okay, if you apply this formula and calculate the R equivalent, and then if you apply this formula, you can easily calculate the equivalent EMF of the cell, right? So this is how you can apply. Also the current in the circuit, the formula for current in the circuit will remain the same. Okay, let's see one question. This is cells in series question from KCET. 10 identical cells, each of potential E and internal resistance R are connected in series to form a closed circuit. Okay, so 10 identical cells. How many cells? Number of cells 10. Identical cells means all of them have same EMF. Here EMF is given by E. Okay, EMF is given by E and internal resistance is given by small r. Okay, are connected in series to form a closed circuit. So they are connected in series. An ideal voltmeter connected across 3 cells. So here we have So here we have 10 cells, but a voltmeter is connected across 3 of them. Okay, what is your expected voltage across them? Very interesting question. Now you might think that correct answer is, okay, we have 3 E's, E. So it must be E and whatever current in the circuit flowing, so it must be minus that current into R. Actually it is not 3E minus 3R, that obviously the unit does not match. Okay, and obviously it will not be 13E or 10E minus R. Let's solve this question. Suppose we have an external resistance capital R. Now what is the total EMF? Total EMF is obviously 10 epsilon 10E. Okay, 10E. So E plus E plus E plus E plus E is up to 10 times, so it will be 10E. What is the R equivalent? R equivalent again R plus R 10 times, so it will be 10R. Okay, so what is the current in the circuit? Current in the circuit is given by epsilon equivalent by R equivalent equals to E by R. Okay, so this is the current in the circuit. Now what is the voltage drop across the voltmeter? Voltage drop across the voltmeter is given by V is equal to I into R. You have to be careful. Okay, you can ignore the cells on, completely. You only need to consider the resistances. How many resistances are there? 1, 2, 3. 3 resistances are there. So 3R times the current. So 3R into E by R cancel, so you get 3E. That's what you are expected as well. So 3E is the correct answer in this given case. Don't make things complicated. Easy question, always solve in easy way. Now Kirchoff's rules. Okay, Kirchoff's rule, some say Kirchoff, I say Kirchoff, does not matter, whatever you are used to hear. Maybe in your college the teacher used to say Kirchoff, I say Kirchoff, both are fine, Kirchoff. Okay, now Kirchoff's rule or Kirchoff's rule, basically it consists of 2 rules. First rule states that it is also called junction rule. This junction rule is given in your CBSE book. Okay, NCERT, not CBSE book, NCERT book. Okay, but this also called Kirchoff's current law. Kirchoff's current law, KCL, you might have heard this, because when we are studying, our book used to say this as Kirchoff's current laws. Now they changed the name junction rule. In most international books they use this term now, junction rule, but initially at a few years back it was known as Kirchoff's current law, KCL. Okay, so that is also used in many cases. In fact, if you move into the college, the teacher there will always say KCL, KVL. Okay, so KCL is called Kirchoff's current law. At any junction, the sum of currents entering the junction is equal to the sum of current leaving the junction. So first of all, let us understand what is the meaning of a junction. Junction means, suppose you have a circuit. You have seen different circuit, right? Right, this is an example of circuit. Now any point where more than one resistances are meeting, that is called a junction. Okay, so here we have one resistance, second resistance, third resistance. So 3 resistances are meeting at this point. So this is an example of a junction. Okay, this is also an example of a junction. This is another junction, this is another junction, this is another junction. Sometimes it is also called node. Okay, node analysis. There is a method of solving circuits. This is called node analysis. Node, junction, same thing. Now you have to understand that junction means where more than one resistance meets. So for example, if you travel by train, you will have observed that there are many places, they are called junctions. Bangalore junction, okay, or Mysore junction, where more than one line for different directions meet. That's why they are called junction. Okay, so junction means where more than one resistors meet at a point. Okay, so you might also think that what is the importance of this law. So this importance of this law, I am coming to it just in a bit, but before that let me explain the law. Okay, and even though I am not drawing the complete circuit, you can assume this is a part of a bigger circuit. So here we have suppose three resistors through which current is going into a circuit. Okay, and we have three resistors through which current is exiting the circuit. Okay, so through these resistors current is incoming. Okay, say I1, I2, I3. It's a big circuit, okay, part of a bigger circuit. Some batteries are connected somewhere, and obviously it is not it. There are many other resistances are there in the circuit, but this is a junction. This is a junction through which the current are exiting I4, I5 and I6. Okay, so these three currents are going in, these three currents are going out. It can be not necessarily it will be 3 and 3. It can be like 1 current going in, 3 current going out. It can be like 2 current going in, 3 current going out. It can be anything. Combination of these can be anything. Okay, there is no specific rule. I am just using for example over here. It can be any number of current that can go in and any number of current that can go out. That you have to be careful. Now Kirchoff's current law says that total current that is going in equals to total current that is coming out. So I1 plus I2 plus I3, this is the incoming current. Okay, and that is equals to the current that is going out, I4 plus I5 plus I6. Okay, so sum of all current in equals to sum of all current out. Okay, so this is the basic meaning of Kirchoff's current law or junction rule. Okay, now why this rule is there? Very simple. One basic fundamental property that charges are conserved. Charges are conserved. Whatever the total charge that is going in to the junction, the same amount of charge should go out of the junction as well. Now what is current? Current is charges per unit time. So per unit time, if you take 1 second time, whatever charges are going into the junction, the same amount of charge should come out of the junction as well. So from Kirchoff's current law, basically a reflection of conservation of charge principle. So this is a direct consequence of conservation of charges principle. Based on this statement, objective questions have come in the past and it will come in the future as well. And maybe your year is the question where this question is asked, maybe in your board exam, maybe KCET exam, not in JEE, but KCET and board both, where you can expect this question is a form of MCQ. The Kirchoff's current law is a direct consequence of dash. Conservation of mass, conservation of charge, conservation of energy, none of the above. So you have to identify this is basically conservation of charge principle. Okay, next law is also a consequence of something, so that's why student gets confused, but you have to understand junction rule means where multiple currents going in, multiple current going out, and total charge has to be conserved. So if you understand this by heart, then you can answer this question. You don't need to remember it. Okay, you don't need to mug it up. You just have to understand the concept. That is very, very important. Next is Kirchoff's voltage law. The algebraic sum of changes in potential around any closed loop involving resistors and cells in the loop is 0. So let us understand this very carefully, because this is a very important concept and the application of this law is vast. Okay, and not only in this class, if you are going to study engineering in future or physics in future, even then also you have to apply this law. This is the basic fundamental law, and there are some derivatives of this law as well. So those who are going to study physics or engineering, they will learn about that as well. But this is the basic fundamental of all the laws that you will study in future. Okay, now what is the meaning of that? Suppose we have a circuit. Some circuit is there, the same circuit, let me draw the same circuit. Remember this. Now in this circuit, let me add a cell as well. Suppose this is a circuit. This is not an easy circuit. This is, even though this looks like easy, this is not a very easy circuit unless some specific conditions are met. Okay, now suppose this is resistance R1, R2. Okay, there is another resistance R3, R4, say R5, R6, and here we have a small r, here we have a voltage. Okay, now you can see that this battery or cell will send some current in this direction. Okay, now for finding the current, when we try to find the current in such circuit, we will use Kirchoff's current law. For example, if I say current I is passing through here, okay, and say current I1 is going in this direction, right? So incoming current is, as you can see, is I, and outgoing currents are I1 and I2. Okay, so incoming current is I, outgoing currents are I1 and I2. So what Kirchoff's current law says? Kirchoff's current law says I is equal to I1 plus I2. Okay, and in exams when you write directly I2 is equal to I minus I1. You don't need to write I2. So in the exam, when you are writing in the moment of heat, you have to save some time. So you will write I minus I1. This is how you save time. Now you can find the current in each and every junction, right? Now Kirchoff's voltage law says that the voltage drop across individual resistances in a loop. What is the meaning of a loop? Now for that I have to say this is also I1, because only one current going in and out. So I1, now suppose I3 comes out over here and I1 minus I3 goes in this direction. Okay, so this is how the we generally first stage of the circuit analysis is to divide the circuit into different parts and find the current. So I minus I1 plus I3, this is the current in this resistance. Okay, because this is going in, this is also going in, this is going out, so you have to add them. Okay, you will develop this quality over time with practice. Whenever you see a circuit, try to analyze this circuit in terms of current, then you will develop this quality. It will not come in a day unless you are already a genius. This will not come in a day unless you have already done it. Not only a genius, but if you have already done it, it will come. But if you have not done it, then you have to develop this skill, and this skill will come after 3-4 months of practice. It will not come right now. If you are wondering, maybe this chapter is already done in your college, students are trying to solve it using current circuit theory, and you are always doing wrong. Don't worry, it happens with all of the other students also. I have seen the topper of the college also facing difficulty to solve this question immediately, right? So this skill, someone will pick it up in 1 week, someone will pick it up in 1 month, someone will pick it up in 3-4 months. But what you have to remember that you cannot accept defeat. You have to keep on fighting. If you say this is it, this problem is not for me, I am out, then you are lost, right? So only one thing that can make you lose is yourself. Your fight is with yourself only right now. You are not fighting with anyone else. Your fight is with yourself. If you say I am lost, then only you are lost. If you say I will not lose, then nobody can defeat you. So you have to remember that, right? So now, even though this is a little complicated initially, you might feel and this circuit is a little complicated, I agree, but with practice, with some encouragement, you will be able to master this in some time, right? Now, what is the Kirchoff's voltage law? Kirchoff's voltage law says that if you take a loop, what is the meaning of a loop? Loop, the first thing that comes into our mind, loop means a circle, right? Loop means in a circle. So what is the beauty about a circle? Beauty about a circle is that its starting point and its ending point are same. So if you start running in a circle, okay, basically we sometimes say we are going in a loop, right? Going in a loop means we are going in a circles. Sometimes the same thing is said, we are going in a circles. That means we are not making any progress. We are only rotating in the circle. So it is also true for you as well. Sometimes you start a chapter and then you realize that this chapter is not completed. I have to go back to the same chapter again and again and again and again, and then you are stuck in a loop, right? So loop means something which starts at some point and you have to find a path through which you can reach the same point. So starting point and ending point are same. Those paths are called a loop. For example, if you start from 1, okay, you can go to here, say this is 2, you can come here 3, and you can come back to 4, and then again you can go back to 1. So this is one loop. But is it only one loop? So if you see here 1, 2, 3, 4 is a loop. 1, 2, 3, 4, 1. So whenever we name a loop, we name it like this: 1, 2, 3, 4, 1, or A, B, C, D, A. So what is the significance of this? The significance of this represents a loop. Okay, if you remember, we used to name a rectangle like ABCD. In case of loop, it will be ABCD A. Right? Starting point and ending point are same. Right? Now what else? If you start from here and go to number 2, and then if you don't come back to this path, and if you go to this way, so this is 5, this is 6. Okay, so you can go see, I'm showing it to you: 1, 2, 5, 6, 3, 4, 1. This is also a loop, a different loop, right? In fact, there are multiple loops possible in this given case. You can start from here: 1, 2, 5, 6, 7, 8, 4, 1. This is also a loop, right? This is also a loop. Now for simplification, if you consider this loop only: 1, 3, 6, 7, 8, 4, 1. Okay, that loop we are going to consider because this loop includes a battery. Now remember that in most of the cases, you have to consider, whenever the circuit consists of some battery or cells, you have to consider at least one, maybe in some cases 2 loops which consists of a battery. Okay, but that is very, very important, because the problem you will not be able to solve only by solving non-battery parts. Non-battery parts are generally easy to solve, okay, but that is not always possible without involving the fact that some information is given in the circuit about the battery. So that information you will not be able to solve. Some specific cases it is possible, but not in 99% cases it is not possible to solve the circuit without going into the detail of the battery. Now if you see this circuit, what is the current through, what are the resistances first? From 1 to 2, you will see there is a resistance R1, current is I1. So what is the voltage drop? Voltage drop is our old friend Ohm's law. Last class we have studied. V equals to IR. So voltage drop across any resistance. Okay, voltage drop across any resistance is basically I into R. Now for that we have to consider current through that particular resistance and the resistance of that particular resistance. These two are important things. Okay, so I1 into R1 is the voltage drop across this resistor, plus, and voltage drops generally will be positive if you are moving in the direction of the current. Very important point. If you are moving now, if you notice that this battery is basically sending current in this particular direction. Okay, so and because we are going in this direction, so we can say that voltage drop across this resistor is positive because we are going in the direction of the current. And one more important point, whatever total current going out of the battery, the same current should always come back to the battery. That is also one important point to remember. Okay, why this is very important? Because conservation of charges. So battery is giving out some charge, it wants that same amount of charge back through the negative side, right? Now I1 R1 is the voltage drop across this battery. Now next we will move between 2 and 5. So 2 and 5, what is the voltage drop? Voltage drop is, current is I1 minus I3, resistance is R2, so it will be I1 minus I3 into R2. This is the voltage drop across this resistance. Okay, and for the time being, let me do one simple thing. Okay, no, keep it, let's keep it. And then if you see what is the 6 R6, R6 is the next resistance, and if you see that whatever current is coming over here, the same current is passing through this as well. So R6 into I1 minus I3. V is equal to IR, RI does not matter. Okay, if you want to write current first, resistance second, okay. If you want to write resistance first, current second, that is also fine. So this is the voltage drop across this resistance. Now let's move between 6 and 7, no resistance. 7 and 8, we have a internal resistance small r. So here you have to apply I into small r. Why I? Because as I said, whatever current is exiting the battery, the same current has to be entering the battery. So this is the entire loop. This is the entire loop. Okay, this is the entire loop. Okay, now here we also have a battery between 7 and 8. Now you have to understand this. You can either write this equals to the external voltage, or according to the Kirchoff's voltage law, you have to write this as minus V equals to 0. Why minus V? So if you are going in a particular loop, okay, and when you are crossing the battery, if you cross it from negative to positive, then there will be a negative sign. But sometimes students get confused and they write here equals to minus V. So I will say either remember any one of them, and I generally prefer this one. This is easy to remember when you are solving a question. Now how to remember whether V will be positive or negative? The trick is, if you are moving from the battery in the direction of the expected current from the battery, if you are moving in the direction where you are expecting the current to flow, then V will be positive. But in some cases, in some complicated cases, they will add one more battery which is actually not sending the current in its original desired direction. It is not sending the current in its original desired direction. In that case, here you have to add minus V. Okay, if you are going in the direction of the current, then equals to positive V. If you are going in the direction of desired current, then it will be equals to positive V. If you are going in the opposite direction of the desired current, then it will be minus V. Now what is the meaning of desired current? Desired current means battery will always try to send current from its positive terminal, and it will always try to receive the same current in the negative terminal. Clear? Any doubt, mention in the comment below. I am not receiving too many comments from you of late, so try to answer, ask your doubts in the comment below. I will try and answer them as much as possible, right? Now this law is based on the conservation of energy principle. Okay, V is equal to IR and also V square I is equal to the energy that is exhausted in each of the resistance, V square by R or I square R. So from there you can say that this is basically a form of conservation of energy. So as I said, the previous law is conservation of charge, this law is conservation of energy. Okay, conservation of charge, conservation of energy. This is called loop rule, also called Kirchoff's voltage law or KVL. Okay, loop rule according to your NCERT textbook, KVL is the name that most of the teachers and community use, that is KVL. Now let's see one question. The question is, a current of 6 ampere enters one corner P of an equilateral triangle PQR. So as you can see here, we have PQR, a circuit, okay, part of the circuit. 6 ampere current is entering. Okay, PQR having 3 wires of resistance 2 ohm each. So each part have a resistance 2 ohm. Okay, and leaves by the corner R. So now my question is, if 6 ampere enters over here, how much current will exit? So conservation of charge, if 6 ampere current enters in this circuit, there is no other way to flow. So the same current has to come out from this path as well. Each and leaves by the corner R. Then the currents I1 and I2 are. So you have to find the currents I1 and I2. I1 and I2. So basically, what are the information? Even though this is not directly a Kirchoff's law formula, but you have to initially apply Kirchoff's law, that is Kirchoff's current law. I1 plus I2 must be equals to 6. Why? So this is the incoming current and these two are the outgoing current. So incoming current is 6, outgoing currents must be equals to that of 6. Okay. Now this is slightly easy question. If you see this question in a different form, what the form? If you see this, let me redraw this circuit. Okay, so 6 ampere current is going in. We have 1, 2 ohm over here and 6 ampere current is going out. But this is not it. We also have a 2 ohm over here and a 2 ohm over here. So this is I2, this is I1, right? I1 in this direction and I2 directly. So if you redraw this circuit like this, now the circuit problem is very, very easy. Why it is easy? Because you can see that these two resistances are basically connected in series. These two resistances are connected in series and these two then they are connected in parallel with this other 2 ohm. Okay, so if you remove these two resistance with their equivalent resistance, so what will be the resistance? It will be nothing but 2 plus 2, that is 4 ohm. Right, but in series combination we know that the current in the circuit remains the same, that is I1. So I1 current flows through this 4 ohm and I2 current flows through this 2 ohm. Now do not try to find the equivalent resistance, that will not help you in this case. So what? Now we have to understand that these are connected in parallel. These are connected in parallel. In parallel combination, the voltage drop across individual resistors are same. So what is the voltage drop across this resistor? Voltage drop across this resistor is 4I2. Right? What is the voltage drop? 4I1, sorry. 4I1. This is I1. So voltage drop across this is I1. 4I1. And what is the voltage drop across the lower one? Voltage drop across this one is 2I2. Right? Resistance times the current. So from here we can say that I2 is basically 2I1. So I2 equals to 2I1. Now we have to put this value over here and we get I1 plus 2I1 equals to 6, or 3I1 equals to 6, or I1 equals to 2, or I2 equals to 4. Okay, so I1 is 2 ampere and I2 is 4 ampere. So this is a just to trick you what are the values. Okay, circuit diagram sometimes can be given you like this complicated form, but actually if you think it properly, clearly in your head, you can simplify those circuits with just in a flash. Now these students were able to solve those questions like a flash, as I said. Okay, and you can see their ranks. They have studied from our in-house campuses, offline campuses of Diksha, and achieved this wonderful result in KCET 2026. Not only in KCET, in fact many of them have done well in other competitive exams for NEET as well as JEE Mains, JEE Advanced as well. Now if you want to study, or if you want to recommend any one of your family members to study in our Diksha offline campuses, then definitely there is a link given in the description of this video. You can click on that and our representative will contact you once you fill up the details for your family and friends. Now let's move on to Wheatstone Bridge. Okay, Wheatstone Bridge. Now Wheatstone Bridge is nothing related to wheat or stone. This is a name of a person. Okay, he developed this circuit theory. He developed this design. Okay, now what is Wheatstone Bridge? Wheatstone Bridge is a simple mechanism. It's a simple mechanism where basically you can, if you know any three of the resistors, you can determine the fourth resistor. That was his original idea. Okay, and it had a lot of applications. Nowadays we generally do not use Wheatstone Bridge in a greater effect, but it still have some kind of applications in meter bridge and all, but meter bridge and those are no longer part of the syllabus anymore. But meter bridge is a very interesting concept. It is a very Wheatstone Bridge is very interesting concept. In future you will learn different other applications of Wheatstone Bridge if you study electrical or engineering, or even in physics also it is there. Right now, what is the basic purpose of this? Let us understand. Here, as you can see, this is a very complicated kind of circuit. Okay, 4 resistors are connected like this, and here is a battery connected. Now this is a symbol of a battery. This is not a cell. Okay, here, and it is an ideal battery. Okay, because as you can see, there is no internal resistance shown in the circuit. So it is an ideal battery. More than one cells are connected, and here, once the current reaches at this point, it breaks into two parts, I1 and I2. Okay, then again when it reaches this part, it breaks into another two part, I3, and one more current. Okay, let's see, this current in this direction is say IG. Okay, current IG. Now one more important point I forgot to mention in the circuit analysis part is that when you solve any circuit, not this circuit, any circuit, if you assume the current positive in particular direction, and after solving the question you realize the value is coming out to be negative, don't be afraid. It is very much possible, because the direction of current, whatever you have assumed, can be in the opposite direction. So if that's happened, that means the direction that you assumed is not correct, the direction in the opposite direction, that's why it is coming out to be negative. So that is also very much possible. So for example, I assume the correct current direction in this case is IG in this particular direction. Okay, but if I solving this circuit, if I get negative IG, then that means that current is not flowing in this direction, current is flowing in the downward direction. As you can see, current can flow in any direction. From this point it can come in this direction, from this point it can go in the upper direction as well, right? So both way it is possible. So that is why current directions are sign of the current is not important. As long as you are solving it properly, you might get a negative value. Don't be afraid. Negative value means current is flowing in the opposite direction. Okay, now so this is the current IG, right? Now the simple idea of Wheatstone is that if you adjust, so these three resistors are known, and this is there is a adjustable resistor R, okay, and generally there is a small resistors which unknown resistance that you are trying to measure, that is connected in series with this R. Okay, that part is not there, so that application is no longer part of the syllabus, so that's why it is not there. When the telegraph, if you remember telegraph system before telephone, there used to be something as a device called telegraph, which is to transmit messages across distance, okay, from maybe like if you want to send a call to your friend, or if you want to send a message to your friend who is staying very far away, okay, how you will do that? Now, right now you can even WhatsApp him, or you can send him a message in Snapchat, and he will get that, right? But back in the 60s and 50s it was not easy. Okay, that time even before that, okay, in 30s and 20s, that point of time there was no telephone call. You can not even call your friend. Okay, so that time you have to send messages through, suppose you want to send some messages, urgent messages to someone, that time you have to use a device called telegraph. Okay, that was again similar like of a telephone, but the mechanism was completely different, and for that telegraph device there is something called a post office box. That post office box is a very important device that used to that was like the number of that particular area. So for example, if you are calling your friend, your friend has a particular phone number, right? Similarly, all the different regions across the world have a different resistance value, and only that particular resistance value if you insert, then only the person who is receiving the message can get the message. Okay, and for that this device, post office box, used to be a good use by the people who were sitting in the post office. It was done by the post office people. They used to send the messages not only in the letters also, but also they used to send messages via telegraph. Okay, and this Wheatstone Bridge was actually the mechanism to determine the resistance for those post office people. Okay, but now that is no longer in use, completely obsolete technology, but the method is still very, very interesting. What is the method? That if you adjust this resistance R, what you will get, you can make the current through this internal galvanometer, the inter-between galvanometer, you can make it zero. You can make this current through this internal galvanometer to be zero, and that is called the balanced condition of Wheatstone Bridge. Balanced condition means in balanced condition, the current through the galvanometer becomes zero. The current through the galvanometer becomes zero, right? And there is a particular relationship between the balanced condition, which is given by, condition for balance of the bridge is given by P by Q equals to R by S. So P by Q equals to R by S. There is a mistake over here, I think. P by Q equals to R by S. This will be R, this will be S. Okay, P by Q equals to R by S. P by Q equals to R by S. Also you can remember P by R equals to Q by S. Top by bottom equals to top by bottom. Top by bottom on the left hand side equals to top by bottom on the right hand side. Now what is the importance of this circuit? So once in KCET exam, this question was very, very popular. One question used to come from this concept every year. Last year 2025 it did not came, so maybe it will come in your year. Okay, also the derivation is important for PU board, but this year might be it will not come because it came in the last 2025. Okay, So derivation I will do, as I said, in the PU dedicated series. Some derivations which are conceptually important, I am doing that. This derivation is not conceptually important, that's why I am not doing it. Anyway, you have to understand the concept itself is important, not the derivation. So you have to understand that this resistance divided by this resistance equals to this resistance by this resistance, then the condition of balance is achieved. Now if you have a circuit, the first circuit that I have drawn, if you remember, this circuit is basically a Wheatstone bridge. Okay, so this is P, this is Q, this is R, this is S, and this is G. Now none of the resistances are equal to 0. Okay, none of the resistances are equals to 0, right? So if you, when you solve Wheatstone bridge related problem, there is one more drawing I will show you later on. Okay, there is one more drawing for Wheatstone bridge. Okay, so when you are solving a Wheatstone bridge and if you realize that the bridge is in a balanced condition, how you will know? Suppose the value are given like this. Suppose this is R, this is 2R, this is 2R, this is 4R. Okay, suppose the values are given like this. So you will see that the ratio of these two resistances is half, the ratio of these two resistances is also half. So we will say that the bridge is in the balanced condition. Now in the balanced condition of the Wheatstone bridge, what you can do, you can simply ignore this galvanometer, because no current is passing through this galvanometer. No current passing through this means voltage drop across this is 0, voltage drop is same. So that means you can say that this galvanometer does not exist. For balanced condition, this galvanometer does not exist. So this is how you simplify a circuit. Now you will see that, now you will see that this circuit becomes, whatever was the complicated circuit, now this circuit is very easy to solve. Okay, so here is a battery or cell. Okay, now if you see that these two resistances are connected in series, these two resistances are connected in series and they are connected in parallel combination. So you can easily calculate the equivalent resistance in this particular case, and there are a lot of application on this Wheatstone bridge circuit theory, and many questions do come in KCET, and it had come in the KCET in the past and it will come in the future as well. So let's see this question I was talking about. This came in 2024, KCET 2024. This is the second pattern of Wheatstone bridge. Okay, as soon as you see this kind of pattern, you have to identify this is nothing but a Wheatstone bridge. So as you can see, this point A is connected in between, and this point is connected with the end of the circuit. So that means this resistance is the galvanometer resistance. Whoever having parts connected at the beginning and the end, that resistance is basically the galvanometer resistance. And when you identify that, okay, R by R equals to R by R, that means this circuit is in a balanced condition, right? This Wheatstone bridge in a balanced condition, not, and generally you will not see any questions on unbalanced condition unless once I saw it in a board exam. But in that case they will give you some more values to help you out. Otherwise in a competitive exam you will not see any unbalanced cases. It will be mostly balanced cases, but you have to identify them. Okay, now as you can see, the circuit is in the balanced condition. Okay, this resistance actually does not exist. This resistance actually does not exist. So you can say basically this is like these resistances are connected in series, this is also in series, and their combination is in the parallel combination. So R plus R, 2R, so 2R and another 2R, they are connected in parallel. And what is the equivalent resistance? 2R and in 2R, two equal resistances connected in parallel, that will be R. So R is the equivalent resistance for this combination. R is the equivalent resistance in this combination. Similarly, you can say that this is also another Wheatstone bridge. The second part is another Wheatstone bridge, and this is the common resistance, which is the galvanometer resistance. So there will be no current through the galvanometer. No current means you can simply ignore this and you can remove this part from the circuit. And again, 2R in series, 2R in series. So 4R in parallel. 4R in parallel means 4R by 2, that is 2R. Okay, so 2R is the equivalent resistance for this entire circuit. R is the equivalent resistance for this entire circuit. So what is the total resistance or equivalent resistance? Equivalent resistance is nothing but R plus 2R. Why? Now this R and this 2R, they are connected in series. So this is the equivalent resistance. So 3R is the equivalent resistance. So what is the current in the circuit? Current is basically voltage divided by the equivalent resistance, that is voltage divided by 3R. I think voltage is given V0. So V0 by 3R. So correct answer option D in this given question. Clear? So how you apply Wheatstone bridge principle? Wheatstone bridge principle, just you have to identify the circuit. Okay, this is a Wheatstone bridge circuit, and as soon as you identify, check whether it is a balanced or not balanced. Okay. For KCET aspirants, if you see that this is not balanced, you can skip that question. Unless and until there are some other tricks involved, the circuit will be very, very difficult to solve, and that probably will be a printing mistake. But for JEE students, advanced JEE students especially, there might be some cases where you will face circuits with unbalanced condition as well. Now these are the homework question. Try to solve this homework question and let me know the answer in the comment below right now. Pause the video if required, solve it and mention the answer immediately now. I don't want to wait. As soon as you are seeing this, write the answer in the comment below and I will check it and I will mention whether it is correct or wrong. Okay. Also, if you want to download the PDF of this lecture, then you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description of this video, and if you are watching this video for the first time, then don't forget to subscribe to our channel. Again, the homework question, pause the video, mention the answer in the comment below. Okay, I will check it and I will mention the comment. Right. Now these are the toppers from our YouTube channel. These they all studied from our YouTube channel videos, and they came to our office and had a we had a very beautiful day along with all the students. And this is the #1 channel for KCET in Karnataka. So if you are preparing for KCET, don't forget to subscribe to our channel. I'll be back with the previous year question from this chapter for KCET and then JEE one by one. Till then, bye.